Hello, everyone. I'm Ben Pfaff. I'm a member of the program committee for the P4 workshop. And on behalf of the P4 workshop, I want to introduce Mirik, who's a principal engineer at Altera with more than 32 years of experience in networking technology. At Altera, Mirik is a solution architect working with customers on P4 applications with FPGA-like security, packet scheduling, clock synchronization, and more. He drives P4 efforts inside Altera. And now I'll let him present his talk on virtual IP load balancing with P4. Go ahead, Mirik.
Okay, thank you very much for introduction. Really when I started my journey more than 30 years ago, yes, there is no data centers. Yes, it is the new topic, and you can imagine that that when it was included here, I was even by many years I was not aware how it works. Yes, but after the working with many of my customers, yes, as some of them educated me, and as I started to work with the P4, I just observed that some many things here could be implemented with the P4. Yes, let me show you the starting what is the data center and what happens. For example, because maybe some of you or maybe more people, yes, is not aware how data center works. Yes, and where is how the packet dries, and I want to start from some basic information here until I will describe what we are implementing using the P4 and how we are implementing using the P4 and where the P4 solution are really have the great capabilities, yes, here, and where the flexibility of the P4 really is very important to our customers here. Let's start from the step one. Yes, you have the mobile phone and you are trying to get, for example, getting what happens on the altera.com. Yes, you are writing the text like to www.altera.com and what's happened. Yes, here probably the service www.altera.com or the web page. Yes, here is located somewhere in the data center. But until we will go to the data center, yes, we should change the name www.altera.com into some IP address. Yes, virtual IP address. Yes, and for example, you can see for example, when we made like the NS lookup command, yes, we can see the Altera is address like this one, yes, and our mobile phone will use this address here from DNS, yes, and the DNS is also used to making sure that for example, we're getting the closest data center as possible here. And we are going to step two. We want to go to it is good to introduce the comment about because regarding the data center, very important is to know something how the data center is organized. And the data center is can be the millions of the servers, yes, in the single location. Yes, of course, not every service is using by Altera. Yes, the Altera is the one of the hundreds, maybe thousands of the services running in the big data center, what you can access over the data center. Yes, and also what you get from the DNS is the public IP address, the virtual IP address, public virtual IP address. What it means that with this IP address, your packet from a mobile phone can traverse for example, the internet, yes, and land in the edge of the data center, yes. But how the data center can find, for example, what is your service, yes? It is to the address, yes, when normally you are using, for example, UDP or the TCP, additional parameter which is a part of this service IP of your service is also the port, yes, because the public IPs here or even the virtual IP are very, very expensive, and from our perspective, even for example, company like Altera, like Google, yes, you can see from the NS lookup they use the single IP address, yes, here, which is the public IP address, yes. It is just for the sake, yes, and really your service is located as to, for example, address your virtual IP address and destination port. Yes, when you are just putting on the, for example, the Google Chrome or the other web page here, access the port at the default, yes, and usually are always exist via, for example, the 80 or 443, as depending on what kind of the service you are using here. Okay, we are in the data center. What's happened inside of the data center? Yes, a data center is the very good very good design and very optimal design. Yes, the first of all, for example, the data center is the set of the routers. Yes, here, and this routers here as the when and which drives you. This routers, yes, or the L3 switches, yes, here, because depending on who are you, you can use the different names, yes, here the different vendors call the different devices, but for me it is L3 switch or router is the same here, yes. Inside of the router we have we getting the data center receiving the packet from your mobile phone and see, okay, you have some virtual IP address and port. And what happens here, the switches generally distribute the packet to for example, on base of the ECMP, like trying to load balance, yes, here. But it is, for example, some for the cost, yes, here, it is from the standard switches, yes, the vendors of the switches do not add the special features to the make load balancing on the base of the service, yes, here. It is done because the number of the switches are the very expensive devices, yes, here, and the operators of the data centers, yes, want to save a lot of money, yes, simpler switch, faster switch, making the cheaper the data center, yes, here. So for example, your packet is distributed over from your packet is creating the hash here, and on base of the hash, you with your virtual IP address, there is created some ECMP. ECMP means the equal cost multipath. Yes, here. So that to achieve to get your service, to get your IP address, you can use the still public IP address. It is just in this direction. You can find, for example, the ECMP, which in this example has two legs. Yes, one leg is for example, router top and router bottom. Yes, here, where these routers connect, for example, to the few servers. Yes, here. Of course, the number of the layers here in the data center is of course could be larger. Yes, it could be 3, 4. That it is depending on which switches, but generally every switch of every router doing the same. Yes, they have the same capability. They have some capability to distribute the packet. Yes, at the end, for example, the packet is landing on the server. Yes, here, and but for example, your service is large enough because for example, like Altera, and the service, for example, can be located on the few machines. Yes, here, even for example, you can imagine that everyone, for example, today, after my presentation, just look, okay, we want to see what Altera is proposing. Yes, here. So Altera inside of the data center must be prepared for example, such increasing traffic here. So in this one, for example, the same service is handled on the many servers. Yes, here. Depending, where is the operators have some special application like the smart load balancer here, which distributes, and when you are adding, for example, more servers, we can add servers, modify the ECMP tables, use more routers, and so on here. Yes, it is, and here in this model here, we have for example, you can achieve the service. Yes, and for example, generally the hashing works that way that your connection will be handled on the same server. Yes, but for example, when you will access the second time here, it is not only, probably the different servers will be used here from this one. It is called we call this horizontal scaling. Yes, it is per rack and per server. Yes. But also from the perspective of the scaling of the server here, we have also the load balancing. We have also something what I call the vertical scaling, where, for example, you can have because today the CPUs here has the less many cores. Yes, for example, I don't know, the 100 cores. Yes, even more than 100 cores, where some of the cores could be used, for example, for your service, but for example, others could be used for additional services. Yes, it is why, for example, when you getting to when you want to get your virtual machine in the cloud, you can see, for example, you can get, for example, 10% of the single core of the server. Yes, here it means that for example, there is the 9 other guys. Yes, here who is using the same server or even the same core here to getting your for sharing your server. Is here, and this vertical scaling just make you possible to the driving of the packet, yes, to the specific core or the part of the core which is the running on the CPU. It is what I call the vertical scaling. Yes, when you will write this picture opposite, yes, here, because it is the additional school of the presenting data center that you can see the vertical will be the horizontal and horizontal will be the vertical. But in my picture, I like this kind of the operation. Yes, here. Okay, let's go next here. It's next question what the load balancer asking is here. Can we match the server capacity? That, for example, could be if you have the limited number of the servers. Yes, here, for example, sometimes happens that for example, you have for example, using the 3 cores of this one of the server, but you have, for example, some spare code on the other servers. Yes, here, what happens here? Yes, for example, and on the server you can have some special load balancer. Really, what is example what I'm talking about here, which is based on some approach described by the Google research. Yes, here they call this maglev. It was invented in the Google here, but they presented to the public. Is to, for example, can we, for example, make the even more load balancing here on for example, on the level of the cores, yes, here inside of the data center, or send the packet over some server to server. Yes, here to make sure if the server can handling your data here, because the number of the requests to Altera is so large here that the services, this cores can't handle this one. Maybe we can share this with the additional server. Yes, here. And here, what happens here? This approach here can be done here. But for example, the packets is going to the different servers here from our server must be encapsulated in the tunnels. Yeah, like for example, IP in IP, the VXLAN, GNIF. It is really the most important part. Why we are using the tunnels. Yes, here, and why the tunnels here on the server? Because it is on the server, it is easier to do them. Yes, here, as I said, normally you can imagine, for example, okay, we can make this kind of the load balancing on the router side, but the routers are the much more expensive than servers, yes, here. And normally the routers are the as simple device as possible to just to cut the price of the overall solution. And normally, for example, you are doing this encapsulation using the using this encapsulation using just to for example, software or SmartNIC, yes. And I want to tell you now how we are doing inside of the SmartNIC, yes, because in P4 and together with FPGA, we just created just example in Altera to show how we can make that kind of the load balancing, the reliable load balancing, yes, using the P4 and how it is done here. That, for example, you can imagine this load balancer here and as the really the two operation is in the P4. Yes, the first operation is for example, the service locator here, which is really the ternary search here, where we are using the destination IP, which is your virtual IP address that we get from DNS, dport, and the protocol here. Protocol. And here, on base of this one, we have the packet hash here, getting a packet hash from the 5-tuple. Yes, we implemented the inside of the P4 the extern, which is for example, the hash here, and we are implementing in the P4, for example, some search table when the packet hash is the index to the table. Yes, and for example, we have our very simple example here. We have two paths. Yes, we can push the packet to the local server, hunt packet locally, or we can push server to the additional server. Yes, here. And here, for example, our local service is implemented, is showing this picture. It is our service. And depending on the hash result, yes, you see, for example, the destination 2 is our local service, yes, here. And we can say that, okay, that everything will go into single direction. But for example, this destination is only from the P4, we are talking about the ports, yes, here. So when we have for example, the virtual ports, the SRIOV ports here, we can just, or even if we have the capability to make for example, some kind of the RSS, yes, on the inside of the virtual machine, this destination could be for example, the SRIOV function on the server, yes, which is where your service is connected, yes. In this case, for example, you can have the 1, 2, 3, or even 4 SRIOV functions here, which are the SRIOV function which could be handling your local service. Yes. Additionally, this SRIOV function can have for example, the RSS function to distribute between the cores used by this one. Yes, and also you have the few other destinations. Yes, when you are going to some remote service. Yes, with the destination 1 here, when you are going to the remote server, it is just to, for example, additionally adding the tunnel. Yes, here in our examples, what we are doing, for example, we're getting the IPv4 address, and we are, for example, adding the IPv6 because in the data center, yes, for example, I go back to the picture. This routers, for example, has supports the two networking domain. Yes, one domain is for example, for the public IP addresses. Yes, and the second domain is for internal IP addresses, which is, for example, the IPv6. Yes, here it is normal that the routers support both the IPv4 and the IPv6 lookup tables. Yes, here. It is just to really the sense of the Google with for example, the P4. Yes, here what we can do here. First of all, for example, we can say okay, this is the ternary search. Yes, it is natural construct. Yes, in the P4. We have the packet hash, yes, we have the pipeline, yes. We can add the tunnel, yes, here. We can make the lookup on base of the hash. The index to the table could be anything, yes, including for example, part of the packet hash, yes, because the hash normally is larger than this one, yes, here. We can, with the distribution, we can set the destination with the virtual function locally here. but it could be the NIC on the server, yes. Or, for example, we can choose, for example, number of the, depending on the, what is the configuration here, a number of the different tunnels to the different servers, yes? Because we are just showing, okay, this is the remote service, but this remote service could be the half of the data center, yes. And in the each, for example, in each devices here, we can have such load balancers here with the smart NIC here, which making the load balancing, and for example, your data center or your service can explode to infinite way, yes. That's the extremely good. For example, it is reason why the, for example, the big operators, yes, or the cloud providers say, okay, we can provide you service, the as big service as you want, yes, here. And it is really that true with that kind of the approach with the virtual IP load balancing here. But where is the second thing? Yes, what happens inside of the server? Yes, here. Let's make we choose for example, some magic happens. Also, the magic is called the NAT, network address translation, where, for example, because we are using the public IP, yes, here, and this public IP is used by everyone, yes, here, and public IP are the very, very expensive, as I said, yes, it is expensive in money sense, yes, that not from the implementation, yes, here, for example, in the server, when server decides to for example, sending to the local service here, it making for example, the DNAT, yes, the destination NAT, the destination IP address or the VIP address is changed to the local IP address. It handled by the service, and you can see, for example, that the service running on the server is completely independent. Yes, here it even doesn't know that it is using this virtual IP address. Yes, the guys are using this virtual IP address. Yes, the someone is talking to him to the service using the virtual IP address. Yes, and for example, you are responding here. And in that way, you are doing the SNAT, the source address NAT. So your local IP is sent to the virtual to the virtual IP, so that, for example, your public, your mobile phone will know, for example, what the session was. Yes, because all the sessions are really detected by the 5-tuple. Yes, here. And what happens on the routing? Yes, it is simplest way, because for the responses, yes, when we have this, for example, the IP address, we are using some construct called the default gateway. Yes, so everything, for example, what you send here. Let me go back here. When you are getting maybe the responding, this first IP router has second IP router is my default gateway. The last default gateway, last router say, okay, the internet is here. Just pushing this to the internet routers, and everything works as you're expecting. Yes, here. And for example, how looks like the full P4 pipeline? Yes, we made the example with the specific pipeline, like for example, making the before to the in V6 tunnel. Yes, because here we really don't use any specific external. Yes, here because we can, thanks to the definition of our architecture. Yes, we have all the checksum and for example, all the checksum inside here. So that we are looking also to for example, we parsing the packet. Yes, like everything in the P4. We have the first lookup table, ether type, to check that it is IPv4 or the IPv6. Yes, here we know that the IPv6 could be the tunnel, or for example, you can ask, for example, the packet what you get from your mobile phone, it could be also IPv6. So we are having this, for example, make the service locator. Yes. We're getting something like the next hop table. Yes, here it is the same construct of the router, but really our next hop table is to really ECM table, and it is located. It is really for example, the destination. Yes, here. When, for example, it is local destination that you can making the IPv4 NAT. It is not local. Your deparser here making the encap or the decapping of the encapping of the tunnel. Yes. And here, what is interesting, yes, some people say that, Okay, you can, for example, can forget when you are using the IPv6, you can forget about the NAT. Yes, not true. Yes, here in the data center, NAT is still present. Yes, here. Why? See, sorry. Because the, for example, the virtual IP address could be also the IPv6 address, yes, here. So, and also the IPv6 virtual addresses, public addresses are also the quite expensive here. So, for example, the VIP is located to local IP, and in both cases, the VIP is the IPv6, local IP address will be also the IPv6, and the same as not here. It is just to so it is that interesting use case where, for example, you are doing inside of the data center where you are making making the pipeline making this IPv6 NAT is also some very nice capability of the P4, because in the P4 you just created very similar construct like the IPv4 is here, and everything works here. Yes, that it is really, and also what is the big advantage of the P4 is to the P4 is create the pipelining. Yes, here the P4 is the pipelining concept. Yes, here it is just I talking about the full P4 pipeline. Yes, here because we presenting the packets and it has the very good performance. Yes, here to the, and it is the very useful the tool to making that data center optimization. Yes, here. And how we are testing this one? Yes, we have the two FPGA SmartNICs. Yes, here the one SmartNIC getting the, for example, getting the some. We have two traffic generators, and we just to, for example, have the definition of the ports. Yes, here programming our table. Yes, from our management, and we are sending this packet to the services to checking the, for example, if it works or not. Yes, you can see here that for example, locally, the service address could be the same IP address like, for example, on every server. Yes, because we are using nothing. Yes, and we have the isolation. Yes, what is important from this? What is important from this point here? When we making the NAT operation, the NAT is made only on the local service. Yes, so normally in the older data center, NAT service was the first on the entry of the data center. Yes, it was the very expensive devices. Yes, thanks to the Google approach and what this load balancing locally on the service. Yes, the NAT operation is handled is necessary only for the local. Yes, when you have the, for example, million servers. Yes, you have the million NATs operation instead of having the 1,000,000 times larger devices here making the NAT globally. Yes, here it is also the very nice feature of this load balancing feature. Yes, here. And currently, how you can implement on how you can use or check this one is you can connect with, of course, with the Altera. Yes, here, or you can, for example, work with our partners. Yes, here, who are providing the hardware for the data centers. Yes, one is the India-based the iWave Global, and the second one is the Silicon Denmark, which is making the cards from handling the 200G or even the 400G in this operation. Yes, here. For more details, please contact our partners, or you can contact Altera directly. Yes, here my email address. Yes, I invite you to cooperate with us. Yes, here in the new data center opportunities. Yes, here. Thank you very much.
Thank you, Merrick, for that presentation. Do you have time for a couple of questions?
Yeah, of course, please.
All right. So you talked a lot about what it does. Can you tell us a little bit more about the P4 code? What's the journey that it takes from code into the FPGA and the NIC?
Okay, you have the NIC here. and in the NIC, here you have what we creating. Yes, the most important is the card. Yes, with the interfaces. Yes, it is just to P4 concept. Yes, we have the P4 compiler. Yes, here, and inside of the data center, inside of the FPGA, we creating the something. Well, we have the special architecture which is called the gateway. Yes, P4 gateway here, which really connecting the port, ingress port with some memories here, and we are able to put the part to insert the code P4 code here into the FPGA using our compiler. Yes, if you are using, for example, the cards from our partners, yes, here they have their own architecture, yes, a gateway type architecture. Yes, so for example, you can create such use cases, what I am showing you here, completely without any RTL knowledge. Yes, you need to get the compiler from us, you need to get the board from our partner is here, and you can we have also the card is overall system is managed using the tool, what we call the FPGA software framework, which is the Python-based tool, CLI, where you, for example, because our approach is to be as close as possible to the customer and the enabling of the customers with the easiest tool set as possible. Yes, and using this CLI tool, yes, here, which is really based on for example, on the Barefoot. Yes, here the Barefoot doesn't exist, but its tools still exist. Yes, here, and for example, we are using these tools here, so you can program in the P4 centric way. Yes, here I mean the P4 centric is the no registers here, no C code, everything in the Python. Yes, if you want, of course, in the C++ program this in the C++. Yes, we have the API also, because we providing the table-driven open source table-driven interface API to manage the P4 code. Yes, here we have also the tons of the examples. Yes, here our partners has own examples. Yes, for the data center. Yes, here and it is really, we want to keep this as simple as possible. Yes, it is really you programming when you're using the card from our partners, you programming the P4 code and checking what is the speed up of your solution in data center. Yes.
Great. I'm sure everybody appreciates the simplicity and attention to detail. So just one final question. So you've talked about one particular application here. Are there any others that you want to name or highlight really quickly?
Yes, for example, the first of all, I am in the load balancing here. What we are working and trying to work is to, for example, the stateful applications. Yes, here the stateful means that the inside of the today's in the data center. Yes, but there is the AI. Then the people are going to hardware to implement the NICs. Yes, here, and really what we are working is here. We are working on the use cases where, for example, to get the bigger performance and some big flexibility related to the P4, that we want to show to the customers. Yes, here that okay, let's create your own NIC, for example, with your own congestion control, which are for example. With all the features, yes, what you need, yes, to be handled, but by the NIC working into the data center. Yes, we want to let people innovate. Yes, here in that way. Yes, here it is really for example, the additional important use case. Yes, what the customer are looking for. It also the part of our is to, for example, telemetry. Yes, here you probably are aware of the in-band network telemetry, INTS here, which also could be very easy included to this kind of the load balancing system. Yes, here some of our cards, for example, the silicon card here is to silicon card, for example, has the clock enabled. Yes, we have the clock synchronization. So, for example, you can synchronize your workload. Yes, here to the nanosecond accuracy. Yes, here it is really the something what the for example vendors of the data center operators are looking. Yes, for example, more performance, more accuracy, and also the more information. Yes, what happens on the card. Yes, here it is just what we are can provide. Yes, here to the data center. Yes, also when you have the clock synchronization in the data center. Yes, you can create for example, the new congestion control algorithm. Yes, here the adding of the, for example, some QoS. Yes, here to when you, for example, in the model, like you pay more, get better priority. Yes, here over the network. Yes, here everything could be implemented using this SmartNIC. Yes, here our partners also shows the, for example, okay, let's make the traffic limiting. Yes, here let's pay, for example, per bandwidth what you use. Yes, here let's make, for example, the prioritization of this one. Yes, let's make the, for example, the some kind of the firewall here. Yes, for example, the implementing here the everything from the perspective of the data center operator. For example, cost of the software of the using of the server. Yes, is the very important. Yes, if the, for example, your infrastructure will consume the implementing of the some infrastructure, like, for example, I don't know, the OVS. Yes, here in the software. Yes, will consume the cores. This core can be used for the earning the money, yes, for the monetization of the server or the investment on the operator side. Yes, here. So for us it is very important to go into the, for example, showing the as much capabilities. Yes, in the SmartNIC. Yes, here to move more and more functionality to the SmartNIC versus keeping them, for example, on the software side. Yes, here to let the servers. Yes, here to earn as money as possible. Yes, here.
Well, thank you for that additional insight, and also for the call out to Open vSwitch, and thank you for the talk. And with any luck, some of our audience will be able to interact with you at the P4 workshop in person in October.
Okay, thank you very much.